Yes, please. And we are, I think, live, maybe. Did it say record? Yep, okay. So this week we have linear models. It's not a lot of stuff we're covering there. It's half of it's a review from a math class you had before where you learned about how to graph lines. We're just going to extend that idea to some more complicated data sets. And then toward the end of the week, you're going to take the midterm exam. There are some samples of past exams here. Usually I give paper exams and a take-home version. So I'll open up the take-home version probably tomorrow and give you till Friday to get that done. And the take-home version is kind of like your application problems that you've been doing. You've got a more complicated problem than one of the simpler practice problems, and you have to play around with it. You only get one shot at it. And it's kind of a cross between the practice problems and the homework. So you'll jump in there, you'll answer the questions. It'll probably involve copying some data into a spreadsheet and playing around with it, and then you'll type up some observations based on your work. And when you open it, you can you can keep looking at it until you're done, but you can't check every answer. There's no check my answer for this assignment here. There's just one submit button for the whole thing. You can save your answers as you go, but it's not going to check them. And then you'll have to wait for me to get back to you on that. And then there's the proctored exam, and that's more like a regular kind of exam, but it's online instead of on paper, and it's not actually proctored because I don't like services like ProctorU. I find it kind of creepy that someone's on the video camera watching you in your space in your room. So it actually won't be proctored, so I will change the name of that. Actually, let's change the name of that now. Edit. Exam 1, this one is actually just timed instead of proctored, and the take-home version is not timed. Then this exam is more like the paper exams, kind of a cross between the paper and the practice here. And all the questions in there I took from your homework or from this practice. The only difference between the practice and the timed exam is you just get one shot at each question. And instead of submitting them individually, there's just one submit. There's a save button and a submit button for the whole test. So you just enter your answers and then go to the next one. Enter your answers, go to the next one. And then when you're done, there'll be a submit the whole thing button up here. So unlike the practice where you get to repeat it over and over again and check your answer each time, with both of the take-home, which is untimed, and the timed version, you just get one shot at each question. And then come on page, let's see. The exam 1 take-home question, half of that's graded automatically. It's probably going to be worth 50 points. I'll probably stick with that. So the first half of that grade, like 30 points of it, is graded automatically by the computer because you're typing in some summary calculations like median and standard deviation and mean and things like that. But then you're also going to make some charts for me, kind of like you did on other applications. And so half of this grade won't be immediate. I have to go in and grade it. And the timed exam, almost every question in there will be graded immediately. You'll see your score after you submit it, but you won't see what's right and wrong until everybody has taken it, which won't be until the beginning of next week. So by the beginning of next week, you'll get to see your complete scores on the two of these. And these are both taken at home on your own. With the timed one, it's about, let's see, how many questions are on the practice? The practice, it's about half the length of the practice, I think. So this has 21 questions, and the timed one has somewhere between 8 and 10 questions. So it's less than half this length. It should probably take you about a half an hour to do, but I'll give you 90 minutes to get it done. So if you have a blank on something, you'll have at least a few minutes to look something up if you want. But I'd recommend you don't consult another human being, please. Although I have no control over that. It's up to you. All right, let's see. Has anyone else joined us? This says yes. Okay, who else do we have here? Come on, why don't you show me everybody here? All right, I think that's everyone. So let's see who we have. Rosanna now. We have Jenna, Olivia, Mikkel, Micah, Monica, And I think I said hi to everybody. All right, does not look like the time should. Yep, Justine, the timed exam is not visible to you yet. Both of them have a password, so you can't get into them yet anyway, but I was still editing the timed one, so I wasn't ready to make it visible and hit the publish button. But I worked on it some more today. I'll work on it some more tonight. And so by tomorrow, that will be visible for you. So tomorrow, I'll release the password for the take-home questions. And then Wednesday, I'll release the password for the timed one. And you'll have till the end of the week. Again, the key important things here, and I'll send a message about this that explains it again, is the take-home one you can open immediately, and you don't have to submit it right away. The timed one, as soon as you enter the password, the clock starts ticking and you can't stop it. So don't start that till you're really ready to complete it. And again, you just get one try, and you don't get to see the answers till next week after everybody else has taken it. All right, any other questions on the exam for this week? Again, it's on your own. You don't need a proctor. One, you have time. You can open it tomorrow and then play with it till the end of the week, but you only get to submit once. And then the timed one, once you enter the password, the clock starts ticking, 90 minutes starts. You should be able to finish it in half an hour if you are ready for it without looking stuff up. But if you stop to look up every single problem, then that's going to take a lot longer. So keep that in mind. Budget your time carefully. Have some notes nearby to look at. So just show up prepared for that. Okay. Usually people do well on these exams if they did well on the practice and the applications. So don't sweat it. Besides, it's also not proctored. You can look stuff up. You'll be okay. It's only an exam. All right, so then we've got some questions on the new stuff. So this week we are playing with linear models. And so there's a little intro here and then some videos, link to the textbook. This link here I just found remarkable. This blew me away, the graphics people make. And I think you gotta click here to actually see it. And there's a video on how to use this site. But this is just one of the most amazing infographics I've ever seen. So right now, this is showing 2019, and we have a graph of, for each dot is a country, and it shows income, average income in that country versus average life expectancy in that country. And if you look, these kind of line up pretty nice. The size of each bubble is what in this case? I believe that's population. Let's see, somewhere on here it says that. Where does it say that? Is this thing hiding some information there? Yeah, oh, it says that on here, the side, population. And you can change, they have a ton of different variables you can play with. So anyway, imagine making, ignoring population, make them all the same size. Well, let me do that. One size. Holy shit, they're big. Okay, can I make them smaller? That's funny. I'm sure there's a button here somewhere. Sorry, I haven't used this in about a year. But those big ass points kind of line up. So we could find a linear model that showed if we knew the average income of a country, we could predict how long people live on average in that country. And when we point to one of these, it tells us what the average income is versus what the average life expectancy is. The other kind of crazy cool thing about this particular thing, and I'll get to those questions in a minute. Let's just reload the page, let's get population back. Is if you play this, they run this through time, so you can see how the different countries changed in. I didn't do population again. Search population. Okay. What did I do? I totally screwed this up. Can I select all somewhere? Help! What did I do? Worked awesome earlier. All right, let's close it and try again. Come on, has anyone watched this yet? All right, some other questions I'll get back to in a minute. Okay, here we go. So if I play this, what it does is it starts in the 1800s, and you can watch as the different countries kind of jump around and what their average life expectancy is and what their average income is in those different countries. And you'll see also the dots will grow and shrink. And then all of a sudden we get into the 20th century and things start changing big time. Look at that, oh my gosh. We're still moving through time at the same pace, but changes have happened in society that are dramatic. And we can see advances in healthcare, increasing life expectancy, and people have better incomes. And that's an awesome graphic. Anyway, okay, let's see, back to some other questions. Answered that. It says the timed exam is due at the same time as the practice exam. Yeah, I will fix the times. All right, that's it. Okay. So let's get to some homework questions. So first question, number 4, are we to use Google Sheets? Let's take a peek at number 4. Number 4 could be done by hand without Google Sheets. So I think I'll just play with that one by hand, and then we can see what it looks like in a spreadsheet. So here's some data. I'm going to stick it in my current page, and then I can try and graph it. So where's my magic pen? So graph paper might be, oh, come on, Zoom, stop messing with me. Oops. Put that up there. All right. Graph paper might not be a good idea if you don't have graph paper. Improvise. So let's see. This is going to be my Fahrenheit there, and this is going to be my Celsius there. Oops, not very straight. Try that again. Straight edge. Fold a piece of paper in half if you need to. All right. So for Celsius, we need to do like let's go 10 there. 20, 30, 40, 50, and 60. And then Fahrenheit, we need to get up to 140-ish. I don't need to graph all the points. Maybe I'll go pretty similar. Let's go 10, 20, 30, 40, 50, 60, 70, 80, 90 would be up here. 10, 20, 30, 40, 50. I don't need to label everyone. This one is Fahrenheit, that's like my Y. Celsius is like my X. So this is going to be my Celsius over there. And I'm just going to plot a few of these points to see what happens, because this one, 0 Celsius would be not going left or right, and then up to 32 would be about here-ish. And then what do we have? 10 goes with 50, that's kind of nice. That's about right there. Let's see, I didn't leave room for negative 10, 14, but if I did, it would be like over here-ish. Did I get that right? Oh no, positive 14. Negative 10, positive 14 would be about there-ish. What else do we have? 20 goes with 68. So that would be about here-ish. And what I'm seeing, these pretty much line up. So I'm going to stop there and just say, hey, look at that. They line up really nice. So what I need to do next is just figure out what's the equation. Classic equation for stuff like this would be y equals mx plus b, and y is my Fahrenheit. B, remember, is the y-intercept, and m is your slope. And in this case, they gave me the y-intercept, 0.32 right there. So I got my b nailed. All I have to do is figure out what's the slope. How do I get from like this point to that point, or this point to that point? So I'm going to take this one because it's probably easier. I need to figure out my rise and my run. And for some of these problems, I recommend graphing on paper and or a computer. And I'll show you how to graph these in Excel in just a sec, or Google Sheets. So my rise, I have to get from 32 to 50. So that is a rise of, what's 50 minus 32? On a good day, that is 18. And then correspondingly, I got to do a run from 0 to 10. So 10 minus 0 gives me 10. And so my slope, m, is 18 over 10, which reduces nice to 1.8, and I got a line. So this line is y equals 1.8 times x plus 32. In a spreadsheet, let's go put it in there. When you copy from a web browser into a spreadsheet, a web browser isn't a spreadsheet, and a spreadsheet isn't a web browser. You have to be super careful on how you select that data. You would copy just from the edge of the word C and let go just after that last number, but don't drag too far, otherwise it'll screw stuff up. All right, and I'm probably getting a homeschool child trying to get my attention. Let's deal with that later. All right, the excitement of this new lifestyle, huh? So copy, if I did that right, switch to my spreadsheet. And if I did it right, I should just be able to Control V, paste it in. If I copy too much stuff from the web browser, then it won't end up in the spreadsheet. Weird stuff happens. And so then what I could do is see if they line up by saying, hey, give me a chart. And for all of the charts in this section, we want a scatter plot. Now they're doing a line chart. You want a scatter plot. And if you're kind of scroll through till you find it. In Excel, you would use the insert and then recommended charts and then look for scatter in there. You can see these line up pretty damn good. You can ask the computer to find the line for you by customizing. And there are other videos about this in the video section. I'm also recording now anyway. Series. And then you would say, hey, can I have a trend line, please? And it says, sure, there's a line. Now, the difference between a trend line and the line chart are dramatically different in that a trend line is an equation. And then under label, I can say, hey, show me that equation, please. And it says, hey, how about 1.8x plus 32? Now, that's a lie. That's not an equation. That's an expression. Notice there's no equals in there. I have to know to think it's y equals 1.8x plus 32, which is the same thing I calculated on my piece of paper. If they line up perfectly, it's super easy to do it on paper, and you get the same answer as the computer. If they don't line up perfectly, it's a bit harder. All right, so that was a long answer to that short question. And then read the fine print on the homework. Am I using the right variables? In this case, it says let Celsius be the letter C and Fahrenheit be the letter F. So instead of a Y, I've got an F here equals 1.8 times C plus 32. And if you type the wrong letter, you should get a warning. So if I put an X in there by mistake, it should say syntax error, which means you type something wrong. Check your variables. You might be using an incorrect somewhere underneath 1. Okay, so it says, oops, one of my variables is incorrect. I got to go back and figure out which one. So if error messages pop up, pay attention to them. Okay, let's see. That was that one. Any more questions? Number 6. All right, so may as well submit this even though I won't remember. Maybe it will today. Number 6. All right, so number 6, make a scatter plot for each of these. Yeah, so this is a good spot to refer to the book or one of the videos that are out there. So let's go open the book. So if you haven't already read the first few sections of chapter 12, which is what we're covering here, please do so. So in this chapter of the book, let's see, am I in the right chapter? Yep, we're doing regression and correlation. That's the intro, and then it jumps to section 1, and section 1 is just about lines. Lines can have a positive slope, 0 slope, or negative slope, so that should all be review. And then it starts getting a little more interesting in section 2. Here they use a calculator, but all my videos I use a spreadsheet, which I'll do some more of today. So they give some examples here, talking about the strength of a relationship, and we'll talk about deviations in a minute. So here they talk about, this is a strong negative pattern because they line up pretty nice. And this one is a negative pattern, but it's weak because they're a little more scattered. This one right here would be not that strong because they're exponential. And this one right here has no pattern. Okay, so there's some examples in the book of what correlation means. And so these are some of those examples right there. And I think there's some more in the next section too. So I'm not going to give all that question away yet because I want you guys to read through the book about that. Some more about slope here, and then the correlation coefficient, which is what question 6 relates to. So please read through this right here. And I'll talk more about the coefficient of determination later. Okay, so read the book, please. Next, question number 8. Let's see what we got. All right, so run a regression analysis on the following data set where Y is the final grade in the math class and X is the average number of hours. Now this one right here, I can see the X values jump nice, or not kind of nice, I guess, 4, 5, 7, 11, 12, 13, 14, 15. So a bunch of them are in order. And as I go from 11 to 12 and 12 to 13, these are not jumping around uniformly. Okay, so just look at those numbers right there. They're a bit scattered. Compare that to question number 4, where we had a steady jump in here. This one jumped by 10 each time, and this one jumped by 18, 18, 18, 18, 18. So if the X jumps by a constant amount and Y jumps by some other constant amount, everything lines up perfectly. In this case, what we're going to see once we graph it is things don't line up so well, but maybe they line up a little bit. Let's take a peek. So highlight, and remember, when you collect data from a web browser, which is not a spreadsheet, you have to be very careful. Start just on the edge of the first letter of the title. Titles are optional but encouraged, and then let go of the mouse just barely, just capture that last letter or number barely, and then let go of the mouse. Control C to copy. If you copy too much over here and too much to the right, it's going to mess things up, most likely on your browser. Okay, so I copied, and I want my spreadsheet back. So this was number 4, new tab for number 8, and then paste it in. So if I selected it correctly, it should paste in just like it did before. If I didn't highlight it correctly, then there's going to be a problem. Sometimes the touchpad on my laptop, it's a pain in the butt to select just right. So worst case scenarios, you might have to retype them. All right, so then I want to say, hey, give me a chart. Do these kind of line up? And the computer, yeah, that's not too bad. There's a rough line going through there. I've got not the best titles here, but hours per week, that's okay, and grade, that's okay. The chart title it picked, where it just sticks them together, isn't so hot. So if I was submitting the chart, I would do a better title, but I don't need to submit this chart, I just need a line out of it. So then we go to customize, and we go to series, and we go say, give me a trend line, and it draws the line. That's not bad. And then I say, hey, show me the equation. And it can even throw r squared in there. Now, again, read that section 12.3 in the book. It explains the difference between r and r squared. They are two different values. One is the correlation coefficient. This r, the square of it, is called the coefficient of variation. And I want you to read about that before I talk about it some more. So there's my equation. Now, it only gives you a limited number of decimal places here. So if you want more decimal places, you have to specifically ask for the slope. And it turns out there is a slope formula, and there is a Y-intercept formula. So I'll show those. And I have other videos that show each of these. Oops, I can't spell. Close enough. So to get this slope they show here, I just start typing equals slope. And it says, hey, you want the slope for a linear regression line? And I say, yeah. Notice it asks for the Y data first. So pay attention to those instructions. So I have to highlight Y first. and then a comma, and then highlight the x values. Oops, that's not a comma. There we go. Close parentheses, hit enter, and what I should see is the same slope they have here. It just shows me more decimal places if I need them. Depends on the problem, how much accuracy we need. Y-intercept is pretty similar. It's the intercept command. It says Y-intercept of a linear regression line, which is what I want. And again, this one says Y first, comma, X second. And those are my values. So now if I need more decimals, I got them. And I can go enter those values. Oops, where'd it go? Back there, into this problem. So it says, hey, what's your equation? This time it does say use Y and X, so be careful of the variables. And 2 decimal places, which I think I had at least for one of them. So 2.96 was my slope. And yours is going to be different. Every time it brings up this problem, you get a slightly different set of data from a larger set. 2.96 is my slope times x plus 41.80, what my spreadsheet said for mine. And then it says, okay, now make a prediction for 11 hours. Now you could just use the table and say, hey, one student at 11 hours got this, but that's not what I'm asking for. Here, I'm asking you to make a prediction based on the equation we just did. So plug in 11 into your equation and see what you get. I want to take this just a step farther and capture this right here. And I want to talk about what the slope and the y-intercept mean. Page, because this is important. So the book goes over this too. All right, so again, this is data on students' hours per week studying. So the X is hours per week studying. And then the Y value here is their grade. Okay, so for example, this student right here spent 11 hours per week on average studying and ended up with a grade of 83.4. This student spent 12 hours per week studying on average and ended up with a grade of 70. Okay? The question is, if you spend more hours studying each week, are you more likely to get a higher grade? Does the data suggest that? Well, when we look at the scatter plot, it seems to suggest that as the amount of study time increases, so does the grade, right? Because we have an uphill slope to that line right there. The correlation coefficient here is probably about 0.9 if we calculate that. So if we calculate the value for R, it's called Pearson. Get the Y, comma, get the X. 0.89, that's about 0.9. If we square that, we'll get the number they gave me here in the sheet. So if I take R and square it, that's the correlation coefficient. Coefficient of variation. So if I take the correlation coefficient and square that sucker, I get that 0.8 they're giving me here. Right? So these are 2 different numbers. So let's make a note. It looks like we have some more guests just join us. I'll say hello in just a sec. This one right here is the coefficient. Coefficient. That needs another F. Variation. And this one right here is the correlation coefficient. Okay, and they tell us 2 slightly different things. And I want you to read about that in the book before I talk about it some more. All right, so back to slope here. So in this case, I have a slope. M was about 2.96. And remember, I found that by asking the computer to look at all these points and find an average slope. Now remember, slope is rise over run. And to get a rise, basically we subtract two y values. So that would be subtracting is a change, and the y is the grade. So that's a change in grade, is the numerator. The denominator, the run, is a change in x, which means a change in hours per week. So change in hours per week. So I could rewrite my slope as a fraction, so there's a numerator and denominator, and I could say it's 2.96 over 1. The 2.96 related to the grade, and the 1 is related to the hours per week. So what does this mean if I put all this together? And let's see, I'm missing some tools. Where'd you go, tools? There you are. Oh, you're still missing. So I want to see tools. Why don't you show me them? Bizarro. All right, glitch in the system. So this information here, I put that into a sentence. What this tells me is that for each additional hour, because this is a change and that's a positive number, per week, student studies their grade will change, right? It's a positive number, it will go up. So their grade will increase by about 3 points on average. That's the interpretation of the slope here. Okay. And in order to figure out that interpretation, you got to write down, what does your numerator mean? What does your denominator mean for the slope? Keep in mind that they are changes, and a positive is an increase. If there was a negative here, it would be a decrease. And so you have to indicate that for each variable. And there are two variables changing with the slope, both the y and the x. So that would be an interpretation of slope. Y-intercept, on the other hand, is kind of interesting. Let's see what that says. What was our y-intercept? Wasn't it around 40? Desktop. And it was about 42-ish if I round. So what does that mean, the y-intercept? Well, let's see. Let's pick a different color. A y-intercept is a point. It's the point we call 0b. And in our case, it was 0 and about 42. The 0 would be hours per week. And the 42 would be the grade. So the y-intercept tells us that if a student spends 0 time studying, they should expect to get a grade of about 42. That's pretty awesome. Wow, no studying and you get a 42. Still not a good grade, but hey, it's better than 0. So the interpretation of the y-intercept would be if a student spends no time studying each week, they should expect to get, running out of room, a grade of about 42. And so we have technology that just finds the slope and the y-intercept. So the act of finding a regression equation is just super easy. Data, plug it in the spreadsheet, say spreadsheet, give me some slope and a y-intercept. So the bigger question here is not can we push those buttons, but what the heck do the results mean? And the slope is important and the y-intercept is important. So I'm going to give another example of that. Let's see, I was going to see who else joined us here. Let's see, April joined us. Hi, April. I don't remember seeing you at first. And I think that's it for the moment. All right, anything going on in the chat? Not at the moment. Okay, so Well, let's see. Oops, too many screens got closed. Let's go here and then what is this one? Oh yeah. So when I have free time, which I haven't had any lately, because this online education is taking up an awful lot more time than I thought it would, I like to mountain bike. And so here I recorded some mountain bike rides I did in the last year. I do a lot of uphill biking, so my times and distances, I'm not going very fast. Like the slowest ride I've done lately was up in the Blue Mountains, and it was so damn steep. My average speed was like 4 miles per hour. But usually it's not that steep, and I can do like 8. Anyway, you can see there is an uphill trend to these numbers. And I can ask the computer to give me an equation for my mountain bike rides. So I go to edit once the data is in there, and then I say under customize series, show me a trend line, and it draws a line through there. And then I say, hey, can you show me the equation? And it says it wants to show me the equation, but I don't see it. Interesting. Let's delete it, start over. Oops, delete the whole sucker. All right, let's try again. Insert chart and customize series, trend line, use equation. There we go. So this says that my equation would be about 7x plus 1. Okay, so what does 7x plus 1 mean here? So let's grab a snapshot of this into my worksheet and see if we can figure that out. So again, the act of finding a regression equation, that's not a problem. We just learn to push the right buttons, no big deal. At first, it's a little bit of trouble pushing the right buttons, and then it gets harder. Oops, that's the wrong one. What did I just do? Back a page. Oh, there's my mountain bike rides. Cut and paste. Okay. So the equation the computer gave me for this, if this is my y right here, and why won't my pen show up? Oh, you're down here, I see. The time, that's my x, and the distance is my y. And the computer said that y was equal to about 7x plus 1. So this is my slope here, right? And my rise would be a change in distance, change in miles. And my run would be a change in hours. So if I write the 7 as a fraction, it would be 7 over 1. And this is change in miles. So this is basically giving me my average speed. So on average, on my mountain bike rides, on the Pendleton trails, I average about 7 miles per hour. It's a lot of uphill climbing there. So for every hour I ride, I go another 7 miles. So if I went for a 2-hour ride, I would expect to do about 14 miles. Now, what's the 1 mean? Remember, the y-intercept is a point, right? 0, whatever b is. And so this would be 0, 1. X is time, so 0 hours equals 1 mile. So this says if I were to just sit there and not bike, I would go 1 mile. What? That's nonsense. So just because you get a number from a computer doesn't mean it's meaningful. So this one isn't. Now, on the other hand, if I get rid of that 1, what would happen graphically? So let's show that graph again. This whole line would just drop down 1 unit. So it would just be, the same slope, but it would be sitting lower down. Okay, so let's capture this and draw what that looks like and decide if it's worth it. Yeah, let's go to the page and get my line tool here. So let's see. 1 is probably about that much lower, maybe. I guess about there. So here would be the line if I took away the y, if I made the y-intercept 0 instead of 1. Okay, it'd just be sitting a little lower. who's got a better line here, the blue line or the red line? Okay, so the computer calculated the blue line. That's called a least squares line or a linear regression line or a line of best fit. There are other techniques for doing it besides this one, but this is one of the better ones. And the difference between the blue line and the red line is this. Let's pull that out. With the blue line that they drew here, I'm going to use some red marks. The point misses the line by a certain distance each time. This point's almost right on, but not quite. This point's a little high. This point's a little low compared to the line. Or you could say the line's a little high compared to the point. And what matters more here, the points or the line? Well, the points are what happened in reality. The line is my attempt to simplify the problem, to force it to line up. All of these red lines I calculated here, I drew in there, those are deviations, right? And deviation is just distance from center, distance from the mean. And this line is like the average for these bike rides. And the idea of standard deviation is related to finding the slope and the y-intercept. And we learned about standard deviation last week. So each of these red lines is a deviation. Sometimes these deviations are called residuals. So deviation, aka residual. And to calculate a deviation, you just take the actual y value and you subtract, the y value from the line. And that gives you this residual here. And what this blue line does is it's the best line that minimizes the lengths overall of all these red lines. It's the only line that has the smallest total set of deviations of residuals. So that red line I drew with the same slope underneath would have more deviation from the line overall, and hence be a bad overall model. On the other hand, it has a better y-intercept, because if I don't spend any time biking, I'm not going to cover any distance. So, so in this case, that y-intercept is not that meaningful, but the slope is. And every situation is different. The slope is almost always meaningful, and the y-intercept depends on the situation. The other thing is, just because you can make a graph between two sets of numbers doesn't mean it means anything. I think there's a pretty good correlation here and causation. So correlation just means, hey, do the points look like they line up? Yeah, okay, it has correlation. Causation means there's a reason the time affects the distance. And the reason is I'm sitting on the bicycle making it move over time, right? I'm the cause of that. So there should be some connection between time and distance. Some examples where there isn't a connection, but things line up pretty damn good. Let's see, I think I've got that back here. Correlation, probably this one. Okay, so this data set here has per capita consumption of chicken. So in the United States, in the year 2006, on average, Americans ate about 61 pounds of chicken per year, right? The numbers underneath are the precipitation in Montana, the average daily precipitation, okay? And it's interesting to note that as we consumed more chicken over time, Montana got more rain. So that's correlation, right? Do the points roughly make a line? The answer is yes, they do. Is there a reason that eating chickens causes it to rain in Montana? That's a little sketchy. Maybe it goes the other way. Maybe there's more rain in Montana forces the rest of us to eat more chicken. I don't think so, okay? So here's an example of where there's correlation, but causation, probably not. I think that's pretty darn sketchy, okay? So just because we can find a correlation between two variables that things kind of line up doesn't mean there's a reason behind it. Science tries to find causation if they have correlation. So correlation is just a mathematical calculation. It can be totally meaningless. In this chicken consumption and Montana precipitation, it's ridiculous, right? Another one I found that had some correlation was per capita consumption of sour cream versus motorcycle riders killed in non-collision transport accidents. As we eat more sour cream, there's more motorcycle deaths in non-collision accidents. What? That's crazy talk. okay? But the points do kind of line up, right? That's correlation, but causation is pretty sketchy here. I doubt it. All right, those are all the big ideas. Nothing going on in the chat. Does anybody have anything else they want to add or ask about? No messages in the chat. Okay, so if you have no further questions, feel free to sign out. If you have a question, let me know. I'll send a note about the exam to everybody today, just to clarify my expectations for y'all. Otherwise, if you have a question, please ask.